Hello everyone. I am Aswini Kumar Sinha, and today we are going to start a very exciting and new series of the project and design is for all of you who are interested in embedded electronics or hardware design. And this series is going to be very adventurous and very exciting one, because in this series we are going to make a very world smallest phone that have the capability. And this phone is not a normal phone. This phone have the touch display. This phone have the Wi-Fi, and you can make a call using this phone. And this phone is act as a smartwatch and a smartphone as well in the very small tiny size. And this phone is 4G enabled. That is another good point for this phone. We are going to do this whole design journey, and we are going to take the whole journey session, and tell you about whole design process in a very part. And this is our first part, and this is our first session. In today we into the part. So in the first part, we will know about the basic component of the phone, then the LCD display that is used in the phone, how to interface that. Then we will interface the GSM module that you can use to to get to access the SIM card, phone calls, SMS, and make all those things. And then we will then we will learn deep inside the 4G chips, so that we can move from the 2G based GSM module to the 4G GSM based module. And then we will design the first UI, a basic UI for the phone. And this is the first part, and in today's session we are going to cover this. Then we will go to the next part, the next session, that is going to be in next Friday of the next month, first Friday of the next month, where we will design the UI. And then we will add the GSM function like calling phone, or getting the SMS, getting the signal, and all those GSM things. And then we will integrate it with the UI. It means we will make a UI on the screen, and using that UI you will able to make a phone call, dial the number like what you do in the phone. And then we are going to make a third session on the next month, first Friday, where we will migrate from 2G SIM to the 4G GSM module. And we will learn to connect with the 4G GSM module and use the 4G GSM module. And then we will use that 4G GSM module for calling, making features, all those things. And then we will make a 4G based phone, and we will also design the UI. Next we will in next month, then we will bring up one more session on the first Friday, that is the part 4. So we are going to do the whole session in 4 parts. So in today's session, so let me first tell you how our phone is going to look and how it is. So you can see this if you can see. Forget this part. Okay, don't look at this part. So this is our phone. This is how our phone will look like. This is. So what this phone have? This phone have this kind of GSM module, a display, and this kind of Indus board. They all are combined together and we will make a phone like this, a small and very tiny one. That is, it's just 3 centimeter size. So it's all possible because of the 3 centimeter coin size Indus board coin. It's very small size with all integrated sensor. So this Indus board coin have integrated gyroscope sensor, integrated magnetometer, so and integrated temperature sensor, and also have the Wi-Fi, and also have the co-processor and 40 plus GPIO. So we are going to hold power of this Indus board coin and combine it with this display module, and then a 4G GSM module or 2G GSM module, and we will make a phone out of it. That will, using which you can make a call. You can receive a call, you can send a message, you can use it as a calculator like you do in the phone. You can play the game on the phone. You can you can do the navigation system using the inbuilt sensor. The display will also do auto rotate like you do in the smartphone. So it's all the features, most of the features that you get in the basic smartphone. It will provide you that in this phone. And this phone will look like this. And I am going to show you a small demo of this phone. So this is the demo. So this is the UI, basic UI of phone that you will see like this. When someone call, it will show you the calling number, and when you touch it, you will able to attend the call using that. So we will make different kind of UI and basic function, and we will make a small phone using that. So how we will do it? We are using this 1 minute, this display, this indus board, this display, this indus board, and GSM module. We will combine all together, and because the indus board have already built in voltage regulators and all those other stuffs like sensor and all other things, and the Wi-Fi, so we don't need any much more component for that. And we will combine this. We will solder this GSM module with the phone like this, and we will make the a smartphone using this. So and it will also give you the dial pad like this. 1 minute, let me show you the dial pad. Let me show you the dial pad. So it will display you the dial pad like this, and you'll be able to type the number and make a call. Like this. You will able to type the number like this. See. So this is a screen. This window is the live window where I will tell you how to connect and everything. This is a live window, and this is the video that I have played to show you how it will look. And let's start our thing. So let's our first part. What are the basic component of the phone that you need in the phone? So one of the basic component that you need in the phone is the microcontroller, the chip. So most of the phone that you use in today's smartphone uses the Snapdragon chip, or Apple have using the other chip. So they are actually SoC, system on chip, or processors. They are for the smartphone that they use. But here we are using the simpler version of that. Here we are using the SoC of ESP that is integrated on this Indus board, that is integrated on the Indus board. That is integrated on this Indus board. This act as our main chip, where we do all the programming and all the stuffs, and we will program it using that. And then the second thing in the phone, what you need is the keypad or a display to show the incoming call and on others. So in older time we use the keypad, but now we are going to use the touch display. So here we are going to use the round touch display. This display model is GC901A round display. But you can also use other kind of touch display if you, but those display are little bit bigger, so your phone will become little bit bigger. But using this, we can make it a small and very wearable phone using the Indus board one like this. You can wear the phone like a watch. So it's a whole phone on the watch like this. So it's very small, tiny size. And I have also published one smartphone making using the e-ink as well. So I am going to show you. So you can refer to this article how you can design your own e-ink display based phone. This is another touch phone that we have designed, and we have published it on the electronics portal. So you can also check it for the reference. So this is the e-ink phone. This is also small size, and this I also use the touch ink display and the GSM module, and it is powered with the Raspberry Pi. So these are the UI that we have designed. So you can also check this design as well if you want to make this phone as well. But we are going to make a next version of the phone that is the Indus board phone. That is the Indus board phone using this Indus board chip. Using this Indus board chip. Using this Indus board chip. So I am telling about what are the basic component of the phone. So one is the main chip. Every phone that you have every phone that must have is the main chip processor that do the all processing and programming. Then they have the GSM chip that allow them to access the SIM card and make a phone call through the SIM card. So this kind of GSM chip. So this is actually the GSM module, but on the phone they have the GSM chip. So this is the chip that is that you see on this phone. The same kind of chip that all those phone have. When you open the phone, you might see the chip like this chip like this. So most of those so all those phone have this kind of chip. 1 minute, let me tell you. This kind of chip. So when you open the phone, when you open the phone cover, you will see the chip like this. You will see the chip like this on the phone. So they are the GSM module that they use. So this is the chip. This chip is the 4G GSM module. But today, in today's session, we will use the 2G GSM module, but later we will switch with this one GSM module that currently you are seeing. This GSM module is the 4G GSM module. So later in version, we will switch to the 4G GSM module. So one thing you need is the main chip, and then the GSM module, then the GSM module, and then other thing is the display or keyboard for the UI. If you have the display, if you have the touch display, this is the touch display, so we can do the touch input and and we can touch the numbers all I have told you, like this. So we can able to touch and interface the phone like this, like this, like this. We will able to interface the phone and type the number and make a call like this. So this is a touch display. It will so this display is a touch display. So we one thing, we need the touch display and the Indus board and the GSM module to act. So this is a 2G GSM module. So you need might need some 2G SIM card with it, and then the microcontroller, and then the touch display. These are the basic things that you need. And in the later version, we are going to change this 2G GSM module with the 4G GSM module, this GSM module, to make it 4G. So at the end, we will make a 4G a smartphone that is a smallest size, only this size for the smartphone, this size for the smartphone. So I also hold the record in designing the world's smallest phone, and this is going to be the this is going to be the part of that. This is going to the second part of my record, and I'm breaking my own record by making this smallest phone. So so these are the basic part that I have already told you that you need. And apart from this, you also need a small battery that used in the smartwatches, so that you can attach with this, and you will be able to access that. So our first part is ready. Now you will get to know what are the basic component of the phone. Those phone have the GSM module and the display and the one main chip using which you can do the things. And now let's learn the next part. How do we connect the LCD so that we will able to interface the phone. So here we are going to use the round display that have the inbuilt I2C touchpad above it. So if I show you the display behind it, so this is a round display that is the SPI based, like as you can see in the camera. So this is the SPI based display that have the 4 to 5 pin. So as you can see, the SPI I work on the 4 pins. That is, one is the MISO, and then the MOSI, then the clock signal pin, and then the reset pin, and then the VCC and ground. So these are the pin for the display. And then we have the touch. We have the touch panel above the display. So that touch panel work on the I2C interface. So that have the I2C pin, that is SDA and SCL pin. So I have soldered all these pin on the Indus board, on this Indus board point, like this to access the display. So after this, when I connect this, our display will be on, and I will able to interface the display. So this is how we will connect the display with the Indus board point. So I am going to show you the circuit diagram as well. So when I power it now, so as you can see, it will give you this thing, display. Yeah. So for the display, first we will make a different kind of a screen. One screen for the dialing pad, then another screen UI for the main screen pad, then another a screen for the calling a screen, then other screen for the calculator, another function for the options and menu, another screen for the getting call or set checking SMS. So if you want to learn how these things work, then you can refer to that article. uh, you can refer to this article. How we will going how the, because basic function behind the thing is same. It's only changed with the microcontroller and the display. Basic method is the same. Like in this article, we will make the different screen. One is for the dialing a screen, one is for the calling a screen, contact a screen, SMS, and then we will make the different screen. Then we'll entry after this making a screen, we will make the function to add the function to that screen, and then we will add a UI after that. After making that a UI, like for the calling and different numeric pad and or touch pad on all those things, we will integrate that UI with the GSM function. So these are the functions. So that part I am going to tell you in the next session, up in the next month, first Friday. But today's session I am going to tell you this only this part. So today we will I have already told you the components that we used in the basic component that you need in the phone, and that we are going to use in our phone design, and then the LCD connection that I am telling you. Then then we will interface the GSM module. Then I will tell you deep inside the chip, and then we will design the first UI, that is the dial pad. Okay, so these are the things that will be covered today, and next part we will cover in the next, and then the next part in the covered in the next session. So you can subscribe our channel and visit to me to our live session next month, first Friday as well. So because this session is going to be in the smaller smart part, because it's a very complex design and it's going to be very long design. So this is how our LCD will connect. Now I am going to show you how you will connect the LCD with the Indus board. So this is the circuit diagram how you will connect the LCD with the Indus board. So as you can see, this 1 minute, yeah. This is the SPI pins of the display. So MOSI I have connected to the pin number 21, SCK I have connected to the pin number 1, and CS I have connected to the pin number 2, and DC I have connected to the pin number 3. And there is a LED back LED of the display. So LED I have connected to the 5 volt and the ground. If you want to control the brightness of this LED, then you can connect this 5 volt to any pins of the Indus board. Okay, and this is the CTS 816. This is the display. This is the display driver chip that is integrated on this display, on this display. So this display driver that you chip, the IC that you have seen on the display, it work on I2C. So this is the connection for that. So I will connect the VCC to the 3 volt, and the ground to the 3 volt, and the reset to the reset, and then the int I have connected to the pin number 7, and then the SCL SDA to pin number 5 and 6. So Indus board have by default SDA I2C pin in say 8 and 9 pin. So if you don't define it in the code, then it will you need to use it. If you want to change it, then you can define in the code. So the Indus board coin that we are going to use, this Indus board coin that we are going to use here. So this Indus board coin have the very flexible GPIOs. So any of these pins on the Indus board can be used as the SPI, I2C, serial, peripheral, and all other things. So this is how we connected display, and this is how we have soldered that those display connector pin on the Indus board. So now our display is ready. Now let's see how we are going to connect the GSM module. So so our GSM module have this GSM module that is SIM 800L. I am using this one, but later we will change this GSM module. Let me show you. Later we will change this GSM module. Later we will change this GSM module with the later we will change this GSM module with the with the what say with the 4G GSM module. But the communication peripheral and the library goes to same because we are going to use the 4G GSM module from the same company, that is Simcom. So you can use any other company GSM module as well, but it's easy for use and we will be able to find the library of that GSM module. So we are going to use the Simcom GSM module. And as you can see, this GSM module, as you can see, this GSM module have these pins. Let me show you. Have these pins. One is the ground pin, and then the TX RX pin. These are the serial communication pins. So this GSM module will communicate with the main controller using the serial port and using the AT command. I will go to tell you details on that, how you can do that. And then there is a ground. There is a VCC pin and there is an antenna pin. So we have connected the antenna. You can also connect the SMD antenna UFL connector using this UFL connector, because most of the phone that antenna that you see in the phone is UFL antenna. Those embedded inside the phone's body. So hide behind the phone body. In older phone, you might have seen those long antenna coming out of the phone. So it is that kind of antenna. So if you want to use this older kind of version of antenna, it's come free with that this one. Then you can add it and you can solder it here. Otherwise you can leave it. So these are the pins for the communication and powering, and these are the pins for the other functions. So as you can see, 1 minute. As you can see, it have one speaker plus pin, one speaker minus pin, then one ring pin, and then one mic plus mic minus pin. So these pins we will connect the speaker and mic, a speaker and mic. And then we will add the ring pin. The ring pin will if you connect the ring pin with the buzzer or any kind of other thing, then whenever you got the incoming call, that will start playing the tune or sound. Otherwise you can connect this pin to the Indus board coin, any of the GPIO pin, and do the digital read and check the incoming call using that as well. So that is also can be done. It depends on you. And so this is the connection. This is how we connect this module. So this is how we connect this module. This is how we connect this module. So this is our Indus board coin. So we will power the GSM module with the ground, and then we will 3 volt, because this GSM module work on 3.3 volt to 3.7 volt. Okay, and then the antenna I have already told you, and the reset is not necessary. And then RX pin going to TX pin of the Indus board, and TX pin is going to the RX of the Indus board. So this is the 44 and 43 pin. So this is the pin that we are going to use as a serial communication to establish the serial communication with this GSM module. So I have already told you that any pins on the Indus board coin can be configured as the serial pin, can be configured as a serial peripheral. So you can connect this RxTX pin and define it in the code to any of these pin. But by default, I am using the by default pin. And then on the other side of this thing, you can add, you need to add either condenser mic, or you need to add the MEMS mic, like mic 1, mic plus, and mic minus, so that when you are talking with the phone, it will able to capture your voice and transfer the voice. And then you also need a speaker. So this speaker will, when you put the phone in the speaker mode, or when any incoming call thing, or all those things, notification things, it will done using this speaker. So this is how you will connect the module. So if we look deep inside this module, what is the deep inside this module? So this module have this chip from the Simcom. This module have the chip from the Simcom, that is SIM 800L chip from the Simcom. And if you look deep inside this, in the data sheet of this is the data sheet of the chip that we are going to use with the thing. So if you go and look deep inside this, then you will able to find that it runs on the baud rate. By default baud rate of this whole thing is the 800. So we have to connect. We have to do it using that. And this Simcom chip communicate with the main controller and give the answer to the main controller using the AT command. As you can see, this is the AT command. So this chip has set of AT command that you can find it here. So this is how the chip module is integrated inside. So it have the power supply part, that and the RTC part. That RTC part will keep the track of the time internally. So it have internal RTC, and then the power supply. Our Indus board also have RTC, so we have two RTC here. So and then the power supply, and then the audio and ADC, so that when you talk with the condenser microphone or MEMS microphone, that converted into the digital. So this is a ADC converter inside it, and then it give you the interface using the GPIO and other things, and then it have the radio frequency module that will control the radio signals or FM signals. So using the same chip, you can also use it as a FM radio, or you can also make a FM radio with the same chip by programming it in the different way. So this is the pins on the SMD chip. The chip that is that used here. The chip that used here. These are the pins of that chip. That chip. So these are the ground pins. These ground pins will connect to the ground. Then VBAT pin will connect to the battery. That is the 3 volt. And then RX pin. This is the communication peripheral pin that you and TX pin that will connect to the RX TX pin on the main chip. And then this is the mic pin. This mic pin will connect it to the mic input condenser MEMS mic or condenser mic. And this is the speaker pin. Then you will get. And rest pin are not necessary to connect. So all these pin are connected by the on the module on this module, and give you as a GPIO output. So all these things are connected on the module and give you as a GPIO output. And this also have the LED indicator to show you the status of that. So this is the LED indicator pin. You will also get the LED indicator pin. Let me see. So this module also work on SCL and SDA pin, I2C, but this module you only the chip also provide you that function, but this chip only works on that what's the USRT thing. And then we go. Let me check the LED pin status pin. So any of these pins have these GPIOs are for the status GPIO. So it can be programmed to show you that connection status, whether it's connected to a network or not. This is for that. So this is how, these are the details how you will connect. So I have told you that we will connect with the 3 volt and all other. So these are steps. So it is the internal connection, how we will power. This is a power supply connection. This is the other connection. So we are going to find the AT command. So this is how our chip looks like. This chip. So this is the AT command using which there are different AT command or that using which you can communicate with the chip, and you will able to find the status and all other things. So first let's test the GSM module. How we are going to test it. So let's first test and connect the GSM module. So as I have already told you, so you need to power it with the VCC and the ground pin and the RX TX pin. So I am putting it inside this. Now this is the button board. This is the button board. Yeah, so sorry, this is the Indus board. This is the Indus board. And now we are taking the ground and VCC ground and VCC of the Indus board point. So black wire is the ground and the white wire is the VCC. So here I have connected the black wire to the ground, to the ground pin, and the other wire to the VCC. So that is the first pin is the VCC. Now let's check the power, whether it is getting power or not. Let me check it again. Let me connect it directly. So as you can see, the module got power. So it's power on, and now we are going to add the RSTX pin. Add the RSTX pin. So now we will program this Indus board. We need to program this Indus board. Now we will program this Indus board to communicate with this GSM module. So now we are going to learn how we will communicate with the GSM chip and how we will use to get the operator ID, the network status, and make a call and make a SMS using this GSM module, and how we will communicate it using the AT command. So let's go to the Arduino ID. So this is our other thing. So this is our code, and this is our live footage. Okay, this is our live footage. See, it's live, and this is our code. So here I have already told you it's work on the hardware serial. So here I am using the 44, 45 pins on the Indus board point, and then we will use the serial port to send the AT command, and then we will receive the serial port to the inbuilt serial port to the to check the output from the from this GSM module. Let me So here we have default and this the default baud rate of this GSM module. Default baud rate of this GSM module. Default baud rate of this GSM module is default baud rate of this GSM module is 4800. So we will set the 4800 and the RxTX pin for the serial one. So this is the serial one for this pin on the Indus board, and this is the default serial, that is the USB serial. This is USB serial. So using this USB serial, I will able to communicate with the serial port on the monitor, and using this serial port, I will able to communicate with the GSM module. Okay. Yeah. Now in the loop function, we will check whatever read from the GSM module, and whatever the command sent from the main serial, that will be transferred to the same to the GSM module over the 4800 baud rate. So now after uploading this code, when you open this, now these are the 80 commands, basic 80 commands that we can check for different things. Like this will tell you certain things about the chip. So when I send this 80 command, so it will tell you regarding the volume level of the chip. So if you want to increase the speaker volume low high, then you can do that. So using this command, we will check the network status, whether it is connected to the network or not. So using this command, we will check the network status. So when I send this command to this GSM module, and this will return the output to the Indus board, and then go to this 1 minute. Yeah, this GSM module will return the output to the serial monitor, whether it is connected to the network or not. So I am going to check it is connected to the network or not. What is the network status? So using ATCHREG, we will get to the network status. So 01, this means it will connect it to the network status. Now I am going to check what is the using this AT command with IMI number or something. Oh, this is the model number of the SIMCOM, using which, and using this AT command. If I send this AT command, so this will tell me the what model number I'm using. So it is sending the model number using this AT command. I will check IMI number. So this is the IMI number. So if I send this AT command, so it will return you the volume. What is the volume of the caller volume? So if you want to increase the volume, then if you can use this AT command equal to 3, then or 4, then it will increase the caller volume according to that. So this will return you the current time, date, and all other things. So let me check the AT command for the. Using this AT command, you will make the call, you will check the SMS and all other details, and you're able to communicate it. So this is how we will in the design, we will communicate with this with the GSM module, and later we will attach this GSM module with this Indus board that have the display behind this, and we will attach this display and this GSM module together. And now if you want to make a call, then we will dial the number and make a call, and using the AT command it will transfer to make a call using that, and it will start making call. So basic process is taking the input and giving the output, acting as a UI interface HMI device. This display act as a human interface device, and using which we can interface the things. And Indus board will process. Indus board act as a sandwich between both them, act as a basic processor to process those things, and communicating with the main GSM module. And this GSM module will help in making call, and receiving call, and all other things. But in the later part of the development of this whole phone design, what we will do is we will not using the AT command directly, because it's will little bit complicated. So later we will switch to the library like this. Later we will switch to the library. So sim 800L library will give you the process. So using this library, you will directly call these functions like set sleep mode. Then the main chip will be bent, go to the sleep, and then set pin mode. Then it will lock the sim with the pin. Then it will give the option to get operator. So using this keyword, you can directly get the operator name. It's Vodafone, Idea, Geo, whatever it is. Then it will also give you the location based on the GSM service, which location it is. And then read SMS number text. So if you want to read some number, what is the number, what is the SMS that you have received, using this read.sms command, this GSM module will return you the SMS, that what are the incoming SMS. And if you want to read particular index SMS, then you have to read SMS for, then it will read the fourth number of SMS. So then you have the another, it will also give the another function, get number SMS. So using the phone number, it will find the SMS of that phone number. The signal quality, then answer the call. So if there is an incoming call, then suppose that I have a UI like this. So suppose that I have a UI like this. UI like this. So when I press this, then touch display will sense that I have pressed to attend the call, and then it will send this command. Yeah, this command, answer call. So when it send this command to the GSM module, it will answer the call, and now our call is attend. So if I want to make a call, then I can make the UI like this. UI like this. So using this UI, I will able to dial and make the call, and after dialing that, it will send this what call, and with the string number that I have dialed, and it will make the call. And this is how it will work. Then we will use this get call status in the loop to get the call status in the real time in the loop, so that if any incoming call is coming, then we will update the screen with the incoming call, and we will attend the call. So using this function, we will use this library later in a later development. So today we are only I am only trying to tell you how we will communicate with the GSM module, and how we are going to develop the phone using this library. So we will use this library later in the production to get the phone call, and integrate with the UI to make the phone. Okay, a small phone. So after that, we need to after this using this 2G with SIM 800L based 2G based GSM module integrating with the phone. And later we will design the next to the 4G GSM module. So for using the 4G, if you want to make this phone enabled with the 4G, make this phone with this phone design enabled with the 4G, then we will replace this GSM module with the 4G GSM module. So here one of the 4G GSM module that is commonly available is this one, this chip. this chip A7670C. So this is the 4G GSM module, and it will support the Geo SIM and all other 4G GSM, 4G SIM, and it is also from the SIM coin, and it's also use the same these kind of AT command to communicate with the main controller, and you will able to do the same thing like that, and the connection goes to the same. So if you look deep behind this 4G GSM module, this is the data sheet of the 4G GSM module. So this is the data sheet of the 4G GSM module. So as you can see the pins on the 4G GSM module, this is how the this 4G GSM module work. So it will give you the pin for the battery, and then the power key to turn it on and off, and then the reset key, and then the ADC for the turning your mic, mic into the digital to analog, so that your mic voice it turn into the digital, and then it will give you the option to use it, so that you can communicate, and these are the pins that this GSM module will give you. So as you can see, checking the data sheet, it support all these classes of these classes of the what's it uh, band, network band, all these classes of network band. So as you can see, it also support the LTE. So it is also support the LTE, that is the 4G LTE thing, using which you can run the 4G GSM sim at well. So this is the 4G GSM module. So this is the footprint of the whole chip, the chip that is used here. So this is the 4G GSM module that we are going to use, and this chip look like this. Chip look like this. Okay. So so this is the data sheet of that chip. These are the ground pin that is goes to the ground, and these are the NCP that will not connected. So ground pin connect to the ground pin, and the BBAT, these BBAT pin will connect to the to the battery VCC or battery or whatever it is, and then you will get the status pin. This status pin connect to the LED that will give you the status by blinking. When it will blink very fast, then it is trying to connect with the network. When it will blink little bit slow, then it get connected with the network, and like this. So it will give the status of that, and then it will give you the pin for the power, so that you can turn it on and off, and then it will give you the on the chip you will find the RxTX. This is the pin that we need to communicate with the microcontroller, or it will also give you the USB connection as well, but this we are not using. And these are the pins: SIM, VDD, SIM data. This is the SPI pin for the SIM card. So this will connect to the SIM card connector. So whatever the connector that you are using, SIM card connector. So these are the SIM card connector. So these are the SIM card connector. They also work on the SPI. You can see these pins are clock, MOSI, MISO, and the VCC, and all these clocks. So this is also work on SPI. So these are the SIM card connectors. So these pins will connect to the SIM card, the SIM card VDD, and then you will get the SIM card ground pin, and then you will get the SIM card data, SIM card clock, and SIM card reset, and SIM card DT pin. So these pin connect with the SIM card, your SIM card connector, and internally. So this is how your chip look like. And so as per data sheet, it works around 1.8 volt to 3 volt. So if you are using the 5 volt thing, then you need to add a regulator to that GSM module. So this is how you connect with the, this is the GSM module. So this is how you will communicate with the GSM module that we are using, like this GSM module. This GSM module or 4G GSM module that I am talking about, both the work on the same thing. So this is your main GSM module, and this is the host. This is this Indus board. So this is the Indus board point, and this is the main GSM module. So we will connect the TX pin of that GSM module to the RX pin of the Indus board point that we will define, and RX to the TX, and then these will not needed, and then you need to power the module, and you will be able to communicate the module. And if you want to connect the ring pin to the buzzer, or if you want to connect the ring pin to the Indus board point, then you can connect it. So now this is how you will communicate with the GSM module, and this is how you will able to check the SMS and make a call using this GSM module. And after we will set this, we will make the code for setting the function, and we will make the UI. So for today, let's make the basic UI, the keypad UI, using which we can dial the number, and later we will integrate the UI in the next part, in the next session. In the next part, we will integrate this UI with the GSM function, so that when you, after dialing the number, you will make the call. So we will go slowly, otherwise it will become complex and you will not able to understand. So you can subscribe the channel and check every first Friday of the month. So and for this project, and this is going to be a long design session. It will complete in total 5 sessions. And on the fifth sensor, on the fifth month, first Friday, we will show you the final design of the 4G phone, that is world's smallest 4G phone of the final design. This phone we will show you the working and demo. And you will, if you buy this component, this Indus board, this round display, and this GSM module, then if you buy this component as a kit from us, then you can also make these whole things along with me in the next session. If you also try this whole thing live with me in the session wise, so you can also buy these components, and you can try it out along with me in the next session. So now let's move to the next part, designing the UI for the display. So for the UI design, so this is the UI design. So here we are using the two library, that is one of the TFT ESPI library. This library supports lots of display. So I am using the GC90A round display. So using this display, I will able to communicate that. And then we are using the CTS 8106065S, because this is a display driver that is this is a touch display driver that this display have. But if your display have any other touch display driver, that like it vary with the many displays. So if you got any other display model from the market, and it have different touch display driver, then you have to change the code accordingly. But by default, most of these display have this same display driver. So I have included both the library. One is for the display, one is for the for other thing to beautify, to give the good look for the fonts and all other things to the display, to our UI. I have used the font free-font.h, and this is the free-font.h. This is not necessary, but I have used the font to beautify, to get a good looking UI for the phone. Okay. So we are going to make a beautiful phone, beautiful, smart, and portable phone that you can wear. It's a world smallest wearable 4G phone we are going to design. And if you buy the Indus board and this display and this and this GSM module, then you can send me the email, and we will make it along with in the live session. You can try it along with me. Yeah, and we will make the live along with each other. Okay. So this is the key strings for the keypad, dialing the keypad. So these are the basic keys that we need while dialing the number from 1 to 9, then a star and 0 and hash. These are the basic keys that we need in the dial pad. So I have described it as it. And then I have created a function to draw those keys on the display. And after drawing this key, we have the function to get which key is pressed. So if that key is pressed, then that will print on the TFT screen, and also save as a string format. So after getting this whole UI design, when I touch that particular key, it will type that number. and save it as a string, like I have dialed 79228965. So this is the phone number the support that I have dialed. So that is displayed in the real time on the display, and that is saved as a string. Now I have if I add the one more button to the that make call button to the UI, and then attach this function, make call. Where is the function? Yeah, call number, and then we will replace it with a string. That's a string. Then it will send that number to the GSM module to make call, and our call, and this is how we will make the call using our phone. So this is the basic function that we need every phone in the need, and this is how we will create the basic function. So for creating this basic function, the first thing is to making the UI thing. So this is how you will make the UI. Now after when I upload this code, let me upload this code. Let me upload this code on the Indus.Board coin. So I am uploading this code on this coin, on this display. So now our thing is ready. So as you can see, this is the display. Now this is the dial pad is ready. So when I touch this number, so this is a dial pad. When now I can dial the number by touching the display and make a call, like 79746696. So I can dial this number by touching this and make a call. Okay, so this is the first UI I have made, and that's it. Otherwise, this session will become so long because this is a very complex project. We are going to make a world's smallest 4G enabled phone. So this is going to be a very big and complex project. So for now, let's stop it, and let's meet in the next session in the next month on the first Friday next month, where we will cover the UI designing, and we will make the first phone call things, first phone call function. And if you want to try along with me, then you can buy the Indus.Board coin from us. You can get the Indus.Board coin from here. So I will also send you the components and the component links here. So you can this Indus.Board coin we are using in the project. So you can buy this Indus.Board coin and the GSM module and the round display, or you can buy the whole kit from us if you want, and then you can try along with me. So we will meet in the next session on the next month of first Friday, and that's all for now.